Hi, in this part of the tutorial, I will show you how to do the setup for the numerical solution. Now when you open up double shear layers Stokes equals to zero point 0.2, you should read data. So after you have read the data, you will have the initial field. But don't worry if you didn't get that. If you did not have that data file, just simply go to solution initialization and initialize the field again because you already have the UDF set up for you if you have followed the previous steps. So go to monitors, double click on residuals and change this to 1e minus 9. Do the same for all three. Next, go to calculation activities, create solution data export. Here change the file type to CFD post compatible and choose the quantities of x velocity and y velocity. Change the frequency to 50 per time step, or 50 time steps per output, and remember to save it in another file. Remember to create a new folder for all three cases or else you will get all the data file mixed up. So for instance, here I created data files Stokes point 2, and then I'm going to save all the data from this case into this file. And after you have done all that, click OK. Next, create particle history data export, which is equally important in this case. So choose injection 0 and browse for the export. Change the particle file name to any file name you want. Let's say p history Stokes point 2 and click OK. After you have done all that, go to run calculations, change the time step size to 0.01 seconds, the number of time steps to 8,000, maximum iterations per time step to 200. But before you run the calculation, I need to warn you that this calculation could cost a lot of time. And if you're running it on a server using the parallel scheme, it might take up to 6 to 7 hours per case. And if you're running it on your personal computer or a usual workstation, it would take around 24 hours to run a single case. So make sure that you have all the time reserved and then click calculate. So here I will just demonstrate what and see what will happen to our case, but I will not finish the calculation. So now we see that it's converging. So I'm going to stop the calculation for now, but keep running it until 8,000 iterations are completed.